What's up guys, Rex here. So as I'll do every Sunday, I'm gonna reflect on my week in medical school and share with you something cool I learned in a week of medical school. So this week we covered a lot of GI stuff, genitourinary, that kind of stuff. But one of the interesting things we talked about was sexual differentiation and determination, especially from an embryologic standpoint. So we talked about in genetics, when you look at genetics of an embryo, sort of the key determination of whether the child is going to develop ovaries or testes is the presence of the SRY region of the Y chromosome. And so that's been known for a while and was a long way to get there. And we actually had one of the main researchers who discovered the SRY region give the lecture, which was super cool. But one of the interesting things she talked about was how not all of our sexual traits or gendered traits that we think of are from the Y chromosome. And she used as an example some really interesting research David Skuse did with people with Turner syndrome. So Turner syndrome is when instead of having an X and an X chromosome and an X and a Y chromosome, you just have a single X chromosome. So these people that have Turner syndrome generally have more of what we would consider a female physiology and anatomy, and that they generally identify as female. And so it was really interesting what he did. He looked at the different cognitive function among Turner patients based on whether they inherited that X chromosome from their mother or from their father. And so what he found was that people who have Turner syndrome that inherit an X chromosome from their mother generally have more spatial awareness and mathematical skills, and patients who inherit their X chromosome from their father generally have more verbal skills and social skills. And so this is really interesting because it makes you think twice a little bit about sort of like what we stereotype different gender strengths to be and how genetics work. And so when you initially hear that, you might be like, oh, the X chromosome from your mother. People who get it from their mother have sort of what we would stereotype as male traits. That's kind of interesting. That's opposite of what I would think. And people who get their X chromosome from their father, they have sort of what we would stereotype as soft female skills. That it's like social skills and verbal skills would be the more stereotypical presentation. But if you think about it a little bit further, a male, in order to be a male, you have to have your Y chromosome from your father, and you have to have an X chromosome from your mother. So having a maternal X chromosome is typically what a male would have. And having a paternal X chromosome, only females have a paternal X chromosome. And so that's sort of opposite of what I would think. But a female also has a paternal and a maternal X chromosome. They have both. And so this gets into this idea of imprinting. So imprinting is where some epigenetic change, and so epigenetic refers to a change to the genome that does not have to do with the base sequence of T's, A's, G's, and C's. And so some change to the epigenetic sequence happens where it's different depending on what parent it is inherited from. And so the theory is that there is some epigenetic imprintation that happens on an X chromosome from a mother that generally conveys more stereotypically male cognitive behavior and cognitive traits. And it's really interesting. I'm not sure how this works, of where does this imprintation only happen within the ovary of a female such that she is not impacted by it, so to speak, that you would think, oh, if a female has an X chromosome that is imprinted in a certain way that conveys male stereotypically cognitive traits, you would think that then that female would express them themselves. But while the female is not expressing it, her male offspring do. And so one of the classic mechanisms of how this imprinting works is either through acylation or methylation, where acylation is a change to the actual DNA backbone that makes it more likely for those genes to be expressed, and methylation is a similar change except it makes it less likely for those genes to be expressed. So there is some process, potentially, this isn't for sure proven, that a female X chromosome has certain things turned off in a way that it changes the expression when it's given to a male, or when a male has an X chromosome, he has things turned on in such a way in his sperm cells that when it's passed on to a female, it turns on those traits and leads to sort of that dimorphism that is, broadly speaking, on a population level, there's a slight trend that men tend to be slightly more spatially aware and have mathematical skills, whereas females tend to have slightly more verbal skills and social skills. And so these are things you have to look on a huge level. Obviously, on an individual basis, a lot of men are going to be more socially aware than women, and a lot of female are going to have much better spatial awareness and mathematical skills. You only can really look at those trends and notice them on a large scale population trend. And so for that reason, this research is somewhat questionable, that there is not a massive population of people with Turner syndrome. But these sort of studies and general principles have been proven in mouse models, showing that a mouse that inherits a X chromosome from its mother tends to have more aggressive behavior that is stereotypical of male mice versus female mice. And there's been some other characteristics like that. And I'll link down below to a couple more studies that sort of just talk about this idea of imprinting on the X chromosome. But I just think that's really interesting, that I initially would have thought of like what our male traits must only be a result of the Y chromosome. But it's actually that there's probably some Y chromosome, but there also very much seems to be potentially that the X chromosome imprinted from a mother and then passed on to a male child results in some male traits, or it could be the other way around, that an X chromosome from a father passed on to a daughter results in some stereotypically female traits on a large population level. And so obviously, again, I want to emphasize, this isn't something that says, oh, all females are this way, all males are this way. You only really notice these differences because they're so slight, but it's on a large scale population level. There are some measurable, repeatable differences that might be a factor from this phenomenon of imprinting on the X chromosome. So that was something really interesting to me. I learned a way to think about genetics and how there are slight gender differences between males and females. If you thought that was interesting, if you have any questions, comments, or concerns, I'd love to hear about them down below. I'll read and respond to every single comment. Make sure to subscribe, hit the notification bell if you want to catch my next uploads. I upload on every Thursday and Sunday. As always, like the video if you like the video, dislike the video if you dislike the video. And until next time, don't be ordinary, go be great.